Okay, question number 3 is our inverse question, but there's also some composites at the end. So I have this parabola. I can see the parabola goes to the left -1 and up 2 and sits like this. So the domain of f is going to be all real numbers, and the range of f will be 2 to infinity, inclusive of 2. Will the inverse of f be a function? Why or why not? No. F -1 will be 1 too many, therefore not a function, because f is a many to 1 function. Okay, part C. Now we're moving to G. G has the same rule as f of x, but has a restricted domain going from a to infinity. State A such the inverse of G of it is a function. Well, if I'm going to make this a function, I need to turn it into 1 to 1, which means I need to get rid of this bit of the graph, which will turn it into a 1 to 1, and it will go from -1 to infinity. Therefore, I'll have a domain of -1 to infinity. Therefore, A has to equal -1. Okay, now this is of my inverse. The domain of my inverse will equal the range of the original, which is G, which will be 2 to infinity. And the range of the inverse will be the domain of G, which is -1 to infinity. And the rule will be y equals x plus 1 squared plus 2. And I swap. Therefore, x equals y plus 1 squared plus 2. X minus 2 equals y plus 1 squared. Y plus 1 equals a plus or minus square root of x minus 2. So y equals -1 plus or minus the square root of x minus 2. Now, I know that my original is -1 and 2 and looks like that. That's g of x. Therefore, at 2 and -1, I'm going to have the inverse, starting at 2 and going down to -1. Sorry, 2, -1. Therefore, I want the positive square root in this case because the inverse is the positive square root. So, coming back up to here, I've got g inverse of x equals -1 plus the square root of x minus 2. And there's its domain and range. The domain goes from 2 to infinity, and the range goes from -1 to infinity. And by the way, that's the domain and range of this swapped around. And lastly, state the rule for the composite. If you place the inverse inside of G, you're going to get x out as an answer. I can demonstrate it. G of x equals x plus 1 squared plus 2. The inverse of x equals -1 plus the square root of x minus 2. Therefore, G of the inverse of x will equal, putting this inside of there, I end up with -1 plus the square root of x minus 2 plus 1 squared plus 2 gives me -1 and plus 1 is 0. The square root of x minus 2 squared plus 2, x minus 2 plus 2, I get x. And lastly, what this wants you to do, I want you to draw this and to write it as G inverse of x. However, I know that for composites, the domain of Goff is the domain of f. Therefore, the domain of G of the inverse of G will be the domain of the inverse of G, and the domain of the inverse of G is 2 to infinity. Therefore, my graph is in actual fact going to have a domain of 2 to infinity, and it's going to look like that. And that's for the complete 2 marks.